Welcome back, everyone. We're going to talk about inequalities. A lot of what you've learned in the past about working with equations works with inequalities too, with a few exceptions. So you have to be careful about that. But remember, you have a strength here before we get to the technical difficulties that can throw you if you're not careful. So here are some properties of inequalities. And some of them will sound very familiar, actually. This first one, it says, and remember, A, B, and C are just numbers. So if A is less than B, then if you add a number C, whatever it is, to both sides, you still got the same inequality. Nice, just like with equations. Second one, if A is less than B, same thing. And C is greater than 0, okay? In the other one, we didn't care about C. It could be anything. In this case, if C is greater than 0, important here, because this changes things a little bit. If that's the case, then we can just do like we did above, multiply both sides by C, if C is greater than 0. Now here's where the catch comes in. If you want to, we can put an unsmiley face in there, or a smiley face, whatever. If you remember this, then you can have a smiley face too. So first of all, A is a number that's less than B. This time though, C is a negative number. That's the important thing. C is a negative number. If that's the case, then when we try to multiply C on both sides, it reverses the inequality. So a negative number being multiplied times both sides reverses the inequality. If you can remember that, you'll be in great shape for inequalities. Now, up here we talked about less than, but it works not only with less than, works with greater than, less than or equal to, greater than or equal to. That multiplying both sides by a negative number reverses the sense of the inequality. If you got that, that's half of the difficulty for this whole section. Read through that. That's exactly what I said, with one exception. This expands it to multiplying or dividing. Dividing is a very close cousin to multiplying, so it would make sense. If you multiply or divide by a negative, then the inequality reverses. Next, here's something that looks similar. It looks similar to AX plus B equals 0, except this time we're going to say greater than 0. Any of these symbols over here can be used. The one we've got is greater than, but you can use any of those three as well. That is a linear inequality. Why is it linear? It's linear because if you look at the x, it's x to the first power. That's what makes it a linear inequality. So it looks like an equation, except it's not quite. So how do we work this? Well, remember, just relax, keep that one rule. If you multiply or divide by a negative number while you're solving it, that inequality gets switched around. It gets reversed. So if this were an equation, we'd subtract 5 from both sides. There we go. And then we'd have minus 3x on the left side. Now, we didn't multiply or divide, so forget about that. We've still got greater than. Now if we add those together, combine those, we'll get negative 12. Now if this were an equation, we would divide both sides by a negative 3 to get our answer. We're going to do the same thing on this one to solve the inequality. Divide by a negative 3, but because we multiplied by a negative 3, then this inequality right here gets swapped around. So it becomes less than instead of greater than. And continue. So this gives us x. That's what we wanted. Less than. And over here we get a 4. So the solution to that linear inequality is all numbers less than 4. Not just some, all numbers. This is different from equations where you end up usually with 1 or 2 or 3 solutions or answers or roots. In this case, if you look on the number line, I'm going to make this real fast. Let's say this is 0 and somewhere up here is 4. Then we're talking about all the numbers are less than 4. So 4 is not included. You put a holodot there. And to show that you've got everything to the left, there you go. And there's a rough draft of your inequality solved. And you can follow that as quickly or as slowly as you want. Remember, these slides are also on Blackboard in case you want to see it. Look for the content area and the chapter in question. In this case, we're still in chapter 1, but we're closing. Okay, now how do we describe some of those? First of all, we've got open intervals and other intervals. They are different. Open intervals means that one side or both sides are strict inequalities. If that's the case, then you're going to use like a parentheses on one side. Now this one says you got all the numbers greater than a to infinity. So at a, this shows that you're not including a, the number a, but you're including all the numbers to the right of a. Now in the second case, in the open intervals, you have two numbers a and b, and you're talking about all the numbers between those two, but not including, because there's no equals here or here. So both at a and at b, you have parentheses. That means a is not in the set, b is not in the set, but everything in between is. That's open interval. And third, similar to the first one, except you've got less than b. So since there's no equals here, see where I'm pointing? If there's no equals there, then we'll have a parentheses at b. And since we want numbers less than it, we go from there to the left. And those are open intervals. What about the other ones? Well, the only difference is if you have an equals, you're going to use a bracket instead of parentheses. So this first one, let's call this number 1, we have numbers greater than or equal to a. So that means start at a, this says include a, so you'll use the bracket, that's why this bracket's here. And greater than means you go in that direction. So a plus all the numbers to the right. Next one, what if we've got a split? Partially strict inequality, partially not. It goes from a to b. A is not included because there's no equals here. So there's a parentheses at a saying a is not there, but everything next to the right is. And stop at b. And because there's an equals here, you'll stop at b and include it with using the brackets. The next one is very similar to that, except we start at a, including a, but we get to b, but don't quite get there. So there's a bracket at a, meaning we include a, parentheses at b, meaning we don't include b, but everything in between. And last of all, numbers less than or equal to b. Less than or equal, automatically you ought to be thinking bracket. So it says less than, so you will go to b, put a bracket there, And since we want less than, the bracket will be pointed in this direction, and our arrow will be pointing in that direction too, meaning B is included and every number to the left of B. Okay, so some other kinds of intervals. We've got a closed interval here. Closed interval means it includes both ends. So this is one way of describing it with interval notation. Notice the brackets, just like on the graph. And over here, A has a bracket, B has a bracket, and the brackets point in the direction of the numbers that we're talking about. The second type in this is the disjoint interval. Disjoint means they're not connected at all. That means you've got two sets and you've got a gap between them. So you've got two sets. So first of all, you take this one, x less than or a, so you know there's no equals here, so you got parentheses, and it'll go up to, but not including a. So here you go. Everything up to, but not including a, parentheses, means not including a. And the other one says pretty much the opposite. Start at B or to the right of B and keep going. And there you go. Parentheses says B is not included, but everything to the right is included. And third of all real numbers. This is written as the set of all x such that x is a real number. Another way of writing this might be the set of all x such that x is an element of the real number set. So if you want to talk about all real numbers, you could just use this. And the interval notation, since it's all real numbers, there's no ending point on either side, so it goes from negative infinity to positive infinity, and the whole number line is included. One special note that negative infinity and infinity are not numbers. They're sort of directions like east and west. You never get to the east, you never get to the west, it's a direction. All right, how do we do this one? And when we do, we'll get the solution set in interval notation. So first of all, we'll copy this successfully, I hope. There's our inequality. Double check, make sure you got it right, because if you make a mistake down here, nothing's going to be right from there on. All right, what I typically like to do is collect the x's on the left side. So the first thing I'm going to do is I'm going to subtract 2x over here, so there won't be any x's on the right, and I'll subtract 2x on the left. Now, what does that do? Well, notice I haven't multiplied or divided by anything, so I'm still going to have less than or equal to. What do I have on the left? Well, I've still got 4 minus, and I can combine those two x's because they're similar terms. And on the right, I've got a 7. That looks pretty good, but the 4 is with the x's. So I've got to subtract 4 from both sides, subtract 4. Now, have I multiplied or divided by a negative number? No. So I've still got less than or equal to. And what do I have? On the left side, the 4 and minus 4 cancel out. I got 0, so just negative 5x left. And on the right, I combine those, and that gives me a 3. Now, I haven't found out what x is yet. Well, just like in a regular equation, if I were solving this as a regular equation, I'd divide both sides by negative 5. So, negative 5x over negative 5, 3 over negative 5. Notice I'm doing the same thing on both sides. Now, we'll stop for a second. Have I multiplied or divided by a negative number? We sure as the dickens did. Negative 5. So this less than or equal to in the middle becomes greater than or equal to. Now we'll clean things up. This gives us x on the left, greater than or equal to. We're just simplifying, so that doesn't change. and on the right we've got -3/5. Now we need the solution set in interval notation. This says everything greater than or equal to -3/5. So we're going to have a lower limit, but not an upper limit. So on the lower limit, we're going to include -3/5. So -3/5 it's going to be the lower limit. Did I get that right? Yes. And we want greater than that. Now, is the 3/5 and -3/5 included? Yes, there's the equals. So we'll put a bracket there because we're including -3/5. Now, there's no end, and we're going to the right, so we'll put a positive infinity there. And infinities, either way, always got parentheses because there is no end point at all. You'd never have a bracket with infinity or negative infinity. Okay, we'll catch up here. And let's see. Got the same, okay, just finishing up. Okay, there's our interval notation, and there's our graphical interpretation as well. Next, this wasn't my favorite years ago, but once I started doing some business things, especially business calculus, revenue and cost became important. Now it says the revenue and cost of a certain product is given as we see here. There's the revenue equation, the cost equation, and X represents the number of units. So maybe we'll write that down. X equals number of units, just in case you have that in a different part of your paper or on a different piece of paper. So that's produced and sold. So you make them and you sell them. That's fantastic. At what production level does R at least equal C? So we've got R is 4x, C is 2x plus 1,000. Now it says at least, so equality is included. Now, how about R? Can it be bigger than C? It says at least C. So yes, it includes numbers bigger than that. So there is our inequality. We just made one of our own. And we want to solve it. Well, we'll subtract 2x from both sides. I'm running out of room down here, but hang on. And before I write this inequality, what have I done? I've subtracted 2x, but I haven't multiplied or divided by a negative. So 4x minus 2x is 2x. This hasn't changed, still greater than or equal to, and on the right side, 2x plus 1,000. Oops, sorry, that's a 0, so we just have 1,000. I'm glad I caught it in time. Now, what I'm going to do next is I'm going to bring it over here, so I've got it. There we go. Now, what would I do if this were a regular equation? I'd divide both sides by 2. Okay, so 2x over 2 and 1,000 over 2. Before I write the inequality in, stop a second. Have I multiplied or divided by a negative number? I have divided, but not by a negative. So this greater than or equal to stays greater than or equal to. So what have I got now? X greater than or equal to 500. And what is it talking about? It says What's the production level for R being at least equal to C? Well, the production level is 500 or more units. 500 or more units will give you a production level at least equal to C. I don't have enough room, but you can write it out. Remember, this was a word equation to begin with, or word question, so your answer should be in the form of a complete sentence. And here's where they go. So that's the start. Revenue is at least equal to C, so you might want to start this way. That's a good idea. And then put the R formula in, the C formula in by substituting, and then solve it. So the break-even point is at 500. If you break even at 500 units, you'll have revenue and cost being the same. It also means that you're not going to have any profit, but you're not losing any money either. So let's move on. Take a look at that. I hope that doesn't scare you too badly. Well, in equations, you only have one equation symbol. With inequalities, you can have two. Notice this weird thing. You've got an inequality there and another one there. It doesn't include any equals, but that's not going to change anything. Now what you have to think is, okay, first of all, I've got three sides to my inequality. I've got a side here, and a side here. So when we do some operation, like addition, subtraction, whatever it is, we have to do it to all three parts. The second thing is, you're going to end up with x. Let's write up here again. -2 less than 5 plus 3x less than 20. What you want to do is end up with x in the middle. Got that? Just like with equations, you want to end up with x, 1x. No minus x, just x. All right, with that in mind, first of all, you want to get x by itself in the middle, so 5 is in the way. I need to subtract 5, so I'll subtract 5 from the middle, but if I do it from the middle, I also have to subtract on the left and subtract it on the right. Now, what does that give me? First of all, I haven't multiplied or divided by a negative number, so the inequalities are going to stay the same. So I'll still have less than here and less than there. Now what do we have? I've got a -7 on the left. In the middle, I've got 3x. That's coming along nicely. And on the right, I'll have 15. Not too far away. I want x here, so if I want x in an equation, I'd divide by 3. Same thing here. So we'll take 3x over 3. That's going to do it for us. I'll have 15 over 3. I'll have -7 over 3. Okay, we're doing the same thing. You can see it with your eyes. Now, have I multiplied or divided by a negative number? No, I'm dividing by 3. So these inequalities won't change their sense. So it's still less than, still less than. Now, let's see what we've got. We've got x in the middle. On the left-hand side, we've got -2 1/3, making that a mixed number. And on the right, less than 5. Now, it doesn't say how we're going to express that, so let's take a look. What does this look like? Well, using interval notation, notice there's no equals on either of them. So you've got a number here. It goes from -2 1/3, and it doesn't include that number, so parentheses, comma. Where does it go to? It goes up to 5, but does not include it, so parentheses goes there too. Now, what would that look like on the number line? Well, if we use the interval notation, we've got negative 2 1/3 here, we've got 5 here, and we'll have this solid line in between them. And last of all, what does that look like with dots? Because some people do it this way. So I'll put negative 2 1/3. I'm doing this, I'm not putting these other marks in just for speed purposes. You don't want to watch me putting slashes in. Okay, negative 2 1/3 is not included. So if you're using dots, that would be an open dot, meaning it's not included. Over here at 5, same thing. And you'll have everything colored or marked in between. Okay, there you go. You just solved a 3-part inequality with my help, but I hope you've picked up enough in the meantime, just 2 extra things. Number 1, there are 3 parts to it. Number 2, whatever happens on one of them, you do to all 3. And you're going to have an interval instead of from one point onward. Of course, they do the same thing I did, except they left it as negative 7/3. If this were a real world problem, you probably would want this negative 2 1/3. I guess we'll accept that, so in case you were interested. Now, we'll step it up a notch. Quadratic inequalities. That just means we've got an inequality right here, and you've got an x squared term in there. That makes it more interesting. Not something that you're going to be thrilled with, but it's something that you can handle because we've talked about that. Remember, this less than could be a greater than, less than or equal to, or greater than or equal to. All of these will apply to that. So, steps for you. Solve the quadratic equation, identify the intervals determined by the solutions, and use a test value from each interval to determine which intervals form the solution set. It sounds complicated. Actually, it's not. This is the most complicated part of it, because after that you're going to be just checking numbers to see how they work. So how does this go? So first of all, you got x squared minus x minus 12 is less than 0. Okay, fine. It's a quadratic because you've got that square. So the first thing you're going to do is write this as an equation temporarily, because you want to find the special x's that are involved, because this might have 2 points and you might have everything in the middle, or you might have everything on the 2 sides. Either this and this, or just what's in the middle. Got that? All right, so first of all, what are those x's that are important? Well, this is a quadratic. You can use the quadratic formula if you're desperate. However, I hope you factor this. There's the factored version. And so x minus 4 equals 0, x equals 4. That's one of our special numbers. X plus 3 equals 0, x equals negative 3 is the other special number. Now, what does this look like on the number line? Let's draw a somewhat crude number line. Our special numbers are negative 3 and 4. So somewhere back here, let's say, is negative 3. Somewhere up here is a 4. What we want to find out is, are we talking about the numbers between those two? Or are we talking about the numbers on one of the sides, or both of the sides? So how do we find? Well, you'll be surprised at how easy this is. So I'm going to change the color of my pen temporarily. I'm going to change it to blue. So what I'm going to do is I'm going to get a number. You can pick any number you like, really. I'm going to pick 0 because it's an easy one to work with quite often. Now, this is my test number. Our test number, call it T if you like, is 0. What are we going to do with that 0? We picked it at random almost. You could have picked out here or out here, but we know right now that either we're going to have everything in the middle or to both sides. So let's see what happens. What happens if we use 0? Well, let's go back up here. Put a 0 in for x. X equals 0. What do we have? 0 minus 0 minus 12 less than 0. Negative 12 less than 0. Yes. Maybe a smiley face even. We'll go a little crazy. So what this means is this test point is in the correct area of all those numbers. So what we've got, notice this is a strict inequality, so we'll have parentheses here because negative 3 is not part of it. Positive 4 isn't either, but everything between is. Why? Because our test point was between those two. We checked it out. It was the right area for our set of numbers, and so we fill that in. If you want to write it another way, we can use interval notation, negative 3 to 4, like that. Remember, 0 was in the middle. That was our test. Okay. So I hope you were able to follow that. Again, reminder, these are the numbers you get from solving the quadratic. It splits the number line at 2 different places. That means you've got a section A, a section B, and a section C. Your job is to find out whether you're talking about numbers in the middle or numbers to either side. And all you have to do is test with a number. Our test number was 0 because it was real simple. If you want to, you could use, say, a 3, for example, because 3 is in the middle interval. That's up to you. You might want to check for yourself because, I don't know if this really works. So remember, we were lucky. We picked an x in this interval, and it worked. Good. It made a true statement. If we'd picked something back here, say a negative 4, that wouldn't work because that's a false statement. If you had picked one to the right, like a 5, and put 5 in for x's, again, doesn't work. So interval B was the one for us. So let's try another one. You can't have too many of them, right? Okay. Now, one thing you might want to keep in mind is that these are quadratics, right? I guess I'd better get the red back here so you can see what I'm doing. There we go. Let's get the red back. There we go. All right. Up here, we're talking about a quadratic inequality. And with the other quadratics we used in the past, we need a 0 there. So if this were 2x squared plus 5x greater than or equal to 12, you'd subtract the 12 from both sides. So you get the 0 there. That 0 is going to keep us happy. All right, so we want to find, first of all, we want to find those special boundary numbers. So we'll take the 2x squared plus 5x minus 12, and we'll set it equal to 0 to find those two numbers. Okay, so how do we do that? Well, let's take a look at this. If you're having trouble factoring that, here's what's called the AC method. Now, I never saw this when I was taking algebra or college algebra, but it's pretty handy. Now, what does AC mean? Well, as a quadratic, this is your A, this is your B, this is your C. So multiply those two together. 2 times 12 is 24. That's real easy, right? You can't complain about that, I hope. Now, with the 24, you factor it as many different ways as you can using integers. First of all, 1 times 24. 2 times what? 12. 3 times what? 8. 4 times 6. 5 doesn't work. And the next one will be 6, but we already had that. Now notice we've got 4 pairs of possibilities. What we want to do is we want to end up with 5x in the middle. Now also, if you're crafty, you'll look at this minus sign with C. That means that these signs, one's going to be a plus and one's going to be a minus. That means when we take these pairs of numbers, we're going to be subtracting. So if I subtract these, I get a 23. Well, that's not a 5. If I subtract these, I get a 10. That's no good. If I subtract these, aha, I get a 5. If I subtract these, I get a 2. So this is the combination I want, 3 and 8. So what do I do with that? Well, here you go. Go back over here. Leave that 2x squared alone for the time being, and leave the negative 12 alone for the time being. Now, instead of 5x, we're going to write it with 3x and 8x, but we want to end up with positive 5x, so we'll have to have 8x and minus 3x. Remember, this is our 5x. We got it by choosing the right combo over here. The next step is we do some easy factoring this time. Factoring the first two terms, only the first two. Ignore the last two. Factoring those, you can factor a 2x out. That's the largest you can factor out. 2x times x gives you the 2x squared. 2x and 8x is a plus 4. Okay, that part's done. We'll look at the second ones. Minus 3x, minus 12. Good. Look at the negative 3x and the 12. Well, first of all, the leading coefficient here is negative, so we're going to put a minus there. If this first term and the last two is negative, this will be a minus here. So if you were thinking of taking out a 3, think again. Take a negative 3 because of this minus. So we'll take a 3 out because that divides into about 3 and 12. And what do we get? Negative 3 times this would be x. Negative 3 times this is a 4. Now, we've got a common factor, just like as if we had 2xa and minus 3a. X plus 4 is your common factor. If you divided both of those by x plus 4, you'd have 2x minus 3. And there you got the factorization. I hope that helps. So we've got this zero factor property to help us solve. So x plus 4 equals 0, or 2x minus 3 equals 0. X equals negative 4, and 2x equals 3, or x equals 1 1/2. Okay, these are our special numbers. So if we want to draw a picture, somewhere back here we have a -4. Somewhere over here we have 1 and 1/2. Those are our special numbers. Now notice that this splits the number line into 3 sections. We've got a section back here, let's call it A, a section in the middle called B, and a section out here called C. Now, here's your chance. You can pick any number you like as long as you don't pick one of those 2 numbers. So let's see, what would be easy? Well, I'm going to take the easy route myself. I'm going to use 0. So my test number is 0. So I'm checking to see whether B is the interval I'm interested in. What do? I'm going back to the inequality and I'm going to put my test number in there. So test is 0. So I've got 2 times 0 squared plus 5 times 0 minus 12 greater than or equal to 0. What do I get? Well, the first 2 are zeros. That's pretty handy. So I get -12 greater than or equal to 0. True or false? Well, that's obviously false. So when I choose B, I chose wrong. But that does tell me where it is. It means this is not where the set of numbers is. It's going to be A and C. Now, it's greater than or equal to, so we'll have this set and this set, and we can color this in and color this in. For intervals, that means we've got -infinity to -4. Remember, oops, it's supposed to be a bracket, isn't it? Because equals is included. So -infinity to -4, bracket, because -4 is included. It's good. On the other side, it starts at 1 and 1/2 and goes to positive infinity. And of course, with all infinities, you always have parentheses. Now, what goes in between those? A couple of things are possible. You could either use the word or actually a better term would be, it's the union of those 2, because your set that's talking about up here includes what's in A and what's in B, all dumped in one huge vat. So there's your solution. And you can follow that on the PowerPoints that you found on Blackboard if you like. See if you can do it before it starts going, or just follow it step by step. Here's where those 2 numbers split the number line into 3 pieces, A, B, and C. And you end up with trying to choose a test value. We chose we chose 0, which was in area B, because it was easy to work with. And that turned out to be false. That means the other 2 are the correct ones. And here are your intervals. And okay, this is for the intervals. Now this isn't the solution, because the solution will have brackets like that. Now this is before we know what's going on here. So here's the real answer. Numbers up to -4, including it. With a union, that means you throw all those numbers together with 1/2 included up to positive infinity. So it's talking about strict inequalities. Strict inequalities are when there's no equals there. That's strict inequalities. Non-strict ones are the ones that have equals in them, there and there. Okay, let's take a look at a different one. We're talking a little bit about physics, but don't worry about that. So you've launched something. Let's say you've launched a small toy rocket. Sorry, I'm not an artist. So it's going to go up in the air from ground level. Here's the ground. And it starts off at 96 feet per second in the air. Here's the equation or the formula that tells you where the projectile is at any one point. If you put in for t how many seconds have gone since you launched it, this will tell you where the projectile is. It says now, when will the projectile be greater than 80 feet above the ground? Well, this is the distance above the ground. So that means greater than that. So the S would be 80. When is it greater than? Well, that means greater than the 80. If you like, maybe you'd like to write it the other way. You could write it negative 16t squared plus 96t is greater than 80. Greater than 80. You might like that better. So let's see, how can we solve that? So let's bring this up here. Negative 16t squared plus 96t greater than 80 feet. When is it going to be above 80 feet? So we'll be looking up in the air at that 80 feet above us. Now, this is a quadratic. You can see that t squared. So what we're going to do is, since it's a quadratic, we need to solve a quadratic. Negative 16t squared. I'm going to bring that 80 over here so that I get the 0 on the other side. I want 0 for a quadratic. Plus 96t minus 80 equals 0. Okay, now you might notice that 8 will divide into all those. In fact, 16 will divide into all of those. In fact, why not divide all those by negative 16? So negative 16 in this would be a nice t squared. Lovely. Negative 16 into the 96, what would that be? Negative 6t. Negative 16 into the 80. A negative into a negative, you get a positive, and that'll be a 5. So what is t? Let's see. We can factor this. The only way to factor 5 is 1 and 5, so this shouldn't be too hard. And to get the 6, that means we're going to have a 1 and a 5, and you want a negative 6, so you'll have to have negative and negative, and that equals 0. The zero factor property says set both of those equal to 0. Well, that is going to give you a 1 in this case, and it'll give you a 5 in this case. So what does that say? We were answering the question, when will a projectile be greater than 80 feet above the ground? Well, here are two special points. When will it be greater than 80 feet? Well, let's see. Put a 1 second here and a 5 second there. And we've got our inequality down here. So I'm going to take the middle route. I'm going to pick a 2 as my test point for this middle area. So I'll put the 2, t equals 2, I'll put it in here. So 2 here will be 2 squared is 4. 4 times 16 is 64, minus 64. Plus 2 times 96, 192, greater than 80. Let's see what we've got. I'm running out of room here. So 192 minus 64 is what? 821. So you've got 128 is greater than 80. Oh, how about that? This was the right the right region for the solution. So the projectile is 80 feet above ground between, sorry about that, 2 and 5 seconds. 1, sorry. That was a test point. The projectile is 80 feet above ground between 1 and 5 seconds. Okay, I hope you're able to follow that. If not, go back and read through it again and see why I made some of the statements I did. Yes, we did it a little bit differently, but this will work. They simplified it before they did it, but this is a good example of they divided by that negative 16 to simplify the inequality ahead of time. That's fine, because they did reverse the inequality. Ta-da! There's our quadratic equation to give us those points. Factor it and find the 2 critical points. That splits the number line into 3 sections. We decided to test in interval B, and I decided, since 2 looked like it might be simple to use, I used 2. That was my test. Oops. Now, solving a rational inequality. Okay, we're going to step it up a notch. Rewrite the inequality so that 0 is on one side and a single fraction on the other side. You need that 0. See what values will cause the numerator or denominator to equal 0. That will give you the intervals. Numerator or denominator equal to 0. And then use a test value just like we did before. If it's a value that causes the denominator to be 0, then we won't include that number. If it makes the numerator equal to 0, it's fine. So make a special note of that. You'll get critical points from the denominator, critical points from the denominator, do not use. In other words, you'll have strict inequalities for those critical points. For the numerator, you're going to be able to use those. Okay. Now this is tricky. What makes it tricky? You might think if you're pretty clever, I'll just multiply both sides by x plus 4. Unfortunately, if you give it some more thought, you don't know whether x plus 4 is a positive number or whether it's a negative number. So you're going to have separate cases. So you're going to be working two problems, you might say. If that x plus 4 is greater than 0, you'll work that out. If the x plus 4 less than 0, then you're going to work that one out. And notice it can't be both, so there's an or here. So the answer you get here will be or this answer over here. We'll take a look at this now. So here's our example. We're going to subtract 1 from both sides, so we have 0 on one side. Well, that makes sense, right? Now multiply by x plus 4. That'll make things a little simpler. Notice that this minus here is going to mean for us that both the x and the 4 have a sign change. When we add those together, we'll have 1 minus x over x plus 4. Not sure about that? Remember, you've got 5 minus 4 and the minus x. Let's go back. Now, watch out with the signs. Now, the quotient changes sign only when the numerator or denominator equals 0. Where does it happen? At 1 and negative 4. Can 1 be included? Yes, because it's from the numerator. Can negative 4 be included? No, because it's from the denominator. So we've just split the number line into 3 sections again. Negative infinity up to negative 4, negative 4 to 1, and then 1 to infinity. Now, what are you going to do? Well, you're going to use a test point. I would be very tempted to use 0 because that would be easy to work with. And if you look back here at the original problem, 0 is not something we can't use. It's negative 4 that we can't use. So I would use the 0. It turns out that 0 will give us a true statement, and that's the right section of the graph. So negative 4, remember, came from the denominator, so it's not included. 1 we got from the numerator, so it is included. If you haven't noticed already, be careful with the endpoints. When you get them from critical points of the numerator, you can use those points. Use brackets, those numbers are included. When they come from the denominator, use parentheses because they're not included in your solution set. So let's solve a rational inequality. We want 0, so we'll subtract 5 from both sides. We need a common denominator so we can add those two together. We certainly can't add these expressions together as they are. So you multiply that 5 times 3x plus 4 over 3x plus 4. There and there. Remember, this is just multiplying 5 by 1 in an exotic form. Now, real carefully, keep that 2x minus 1 over 3x plus 4. You're going to rewrite this one. You'll have negative 5 times the 3x, negative 5 times the 4. Or you can do that first. So simplify, watch out with the signs. So this is what you've got when you add those two together and you add the 0 on the right side. Now you're going to get a 0 from here and a 0 from here. Remember, zeros from here you cannot use, zeros from here you can use. Set the numerator and denominator equal to 0. You're using zeros from the numerator, not using zeros from the denominator. Here are your 2. Here's the numerator. You'll be able to use those x's. And this one, it's from the denominator, so you will not be able to use those as part of your set. It just means that will be a boundary, but it won't be included in the actual problem. So you solve this one. Here's one of those critical points. Solve this one. There's another critical point. And what does that do? That splits the number line into 3 sections one more time. You might want to change this or check it on. I think the easiest way would be to take that negative 21 over 13, throw it in your calculator, and take that negative 4/3 and put that in your calculator. See which one is to the left and which one's to the right. And there we go. The 21 over 13 was on the left side, and because that came from the denominator, it's not included. The negative 4/3 isn't included. Now, which interval are we going to use? Negative 2 from interval A. That's pretty simple. Negative 1.5 from interval B. Now, if you're not too sure about that one, you can take the decimal versions of these two and get something in between. And they already told us that negative 1.5 is between those two. And in interval C, 0 is there. So that's an easy one to work with. I would probably go with this one because I'm going to end up with either A and C or just B. So I'd use the one that has a 0. We'll see what they do. So the solution set won't include either one because you got the less than symbol. Where's the less than symbol from? Sneak back here, right here. So those are your two intervals. They were the outside ones. Remember, I suggested using the 0 from this one. It turned out to be true. Something from this one would have also worked, but nothing in the middle. Well, I hope that gave you a bit of an idea. You might want to watch this more than once. This is a little bit on the tricky side. And of course, as always, write down your questions, bring them to class, and we'll take care of all your questions. You can also stop by the office if you like, but in class is better because someone else might have the exact same question, and I can answer both of yours at the same time. Well, until next time, take care of yourself, and we'll see you in the last section of Chapter 1. We'll talk about absolute values. And this will be interesting, right? Well, I hope you're looking forward to it. See you.